Hello everyone, in this video we're going to be solving a non-standard exponential equation. Now exponential equations are fun, and this one is also a fun one because it's not very standard. So what are we going to do? Well, if you look at the exponents here, we have the x and 1 over x, so that's significant. First of all, notice that x cannot equal 0, so we can safely say that x is either positive or negative. So one thing to notice about x being negative is that if x is actually less than 0, you're going to get some small terms. For example, suppose x is equal to -1. You're going to get like 1/2 plus 1/2, which is barely 1. What if x is equal to -1? The answer is going to -2, I mean. So the answer is going to be even less than 1. So basically, it's just going to be around 1. And notice that it's going to get smaller and smaller. So we can basically exclude the fact that x is less than 0. So let's go ahead and focus on x being positive. Now what happens if x is positive? Well, first of all, notice that we have the x and 1 over x. So what I'm going to do is I'm going to be using an inequality here, which is called AMGM inequality. So what is AMGM? It just says that the arithmetic mean of a bunch of numbers is greater than or equal to their geometric mean as long as those numbers are positive. Okay, great. Now in this case, since our x is positive, we should be good. Now how am I going to use this? First of all, I'm going to establish that, or at least accept without proof. If you want me to prove it, I could probably do it too. But I think this should be well known. If you add a number, we're talking about a positive number here. If you add a number to its reciprocal, the answer is always going to be greater than or equal to 2. Now why is that happening? If you make a common denominator, or if you go ahead and subtract 2 from both sides, and look at this expression here, you're going to get x squared minus 2x plus 1 in the numerator and x set in the denominator. Notice that the top is x minus 1 quantity squared, and x is always positive. So you're talking about a non-negative quantity here, which proves that our inequality is true. So if x is positive, of course. So if x is positive, this is true. What does this tell me though? I don't have the sum of these two terms because these are the exponents. Well, what I can do is, along with the AMGM inequality, I can use this to establish some boundaries for my equation. Now, let's go ahead and do that. Since x plus 1 over x is greater than or equal to 2, I can basically say that in my expression, if I just raise it 2 to the power that, I'm going to be getting something like 2 to the power x plus 1 over x is greater than or equal to 2 to the power 2, which is equal to 4. So this basically tells me that 2 to the power x plus 1 over x is going to be greater than or equal to 4 all the time if x is positive. Cool. Now, what does this have to do with our expression? Our expression involves the sum of two terms, and that happens to equal 4. Isn't that interesting? So we're kind of getting the same thing from here. So let's go ahead and use AMGM now with two terms, which is 2 to the power x and 2 to the power 1 over x. So here's how AMGM goes. You add the numbers, divide by 2, and then you multiply the numbers and square root. That's the geometric mean. And AMGM says that the arithmetic mean is always greater than or equal to the geometric mean. But notice that we have 2 to the power x plus 2 to the power 1 over x here, which happens to be 4. 4 divided by 2 is equal to 2. So we basically had 2 on the left-hand side. Let's flip sides. This gives us the square root of 2 to the power x times 2 to the power 1 over x is less than or equal to 2. If you square both sides and add the exponents, because that's what you're going to get from there, you'll get 2 to the power x plus 1 over x is less than or equal to 4. But notice that in this expression, we basically got that expression is supposed to be greater than or equal to 4 if you start with the assumption that x plus 1 over x is greater than or equal to 2, which is true for positive x's. Now, what is that supposed to mean? Well, we kind of have like two contradicting statements, but this means that 2 to the power x plus 1 over x is supposed to equal 4. Okay, now what is that supposed to mean? Let's talk about that. Well, it just means that x plus 1 over x is equal to 2. So what? Well, when is that true? We said that, x plus 1 over x is always, right? X plus 1 over x is always greater than or equal to 2. Now, when they're equal, it just means that x and 1 over x are the same thing. We can also do the same thing with the AMGM. If the AM equals GM, then the numbers have to be equal, because the arithmetic mean of two numbers is equal to their geometric mean if the numbers are equal. For example, take 8 and 8, right? If you add them up and divide by 2, you get 8. If you multiply them and square root the result, you get 8, so that you get the same number. Okay, cool. So this just means that x equals 1 over x, but remember that x needs to be positive. From here, we only get one solution, x equals 1, and that just happens to be the only solution to this equation. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed the video. Please let me know. Don't forget to like, comment, and subscribe. I'll see you tomorrow with another video. And until then, be safe, take care, and bye-bye.